Good evening everyone. So welcome to my YouTube channel Math Sastram. Today we are going to see fourth lecture on infinite series. Today we will study limit comparison test. Okay. So let us start today's session now. So what is the statement of limit comparison test? Limit comparison test. Limit comparison test. Okay. Okay. So let summation n goes to 1 to infinity an and summation n goes to 1 to infinity bn be two positive term series, positive term series. Okay. Then positive term series. Number one, if limit n tending to infinity a n b n is equal to L, where L is finite and non-zero, then both this series converge and diverge. Both this series converge or diverge together. Or diverge together. Okay. Second one, if limit n tending to infinity a n upon b n is 0 and the series summation n goes to b n is convergent, then the series summation n goes to 1 to infinity a n is also convergent. But converge is not true. But converge need not to be true. Okay. Third, if limit n tending to infinity a n upon b n is equal to infinity and series n goes to 1 to infinity bn is divergent. Okay. Then the series summation n goes to 1 infinity an is also divergent. Okay. So We will prove this limit comparison test in next lecture. So we will see the how to apply this test to show some series is convergent or divergent. You see that first statement is that limit is infinity and Bn series is divergent, then the An series is divergent. But converge need not to be true. Okay. First we see that how this test works. Okay. How this test works. So this was first example. Example first. So I am writing example. See this example. Is the series summation n goes to 1 to infinity 2n plus 1 upon n square plus 2n plus 1 convergent. Okay. Solution. Or you write this question in the following form. Is the series is the series is the following series convergent? Is the following series convergent? What is the series? I am writing below. This is 3 upon 4 plus this is 5 upon 9. This is 7 upon 9. Okay. This is 9 upon 25 and so on. Okay. So solution, what is this? Solution. So how to write this? How to write this? So this is in numerator it is 3, 5, 7. So summation n goes to 1. We can write this series. We can write this series in this form. So above is 2n plus 1 and denominator is n plus 1 ka square. The above series can be written in this form, summation form. So what is an? An is 2. An is 2n plus 1 upon n plus 1 ka square. Now take Bn. Take Bn is equal to Bn is equal to 1 upon n. Now you see that this series is positive term series. So this is 0. So this implies this is positive term series. Okay. So because Bn is equal to 1, this implies summation n goes to 1 to infinity 1 upon n is also positive term series. Now this series is divergent. This Bn series is also summation n goes to 1 to infinity bn, that is summation n goes to 1 to infinity bn is divergent series. Divergent series. Now, if we can show an upon bn limits will be finite and non-zero, then we conclude by limit comparison first part. Okay. By first part, if we can show this limit is finite and non-zero, then by first part we can say that the series is divergent because both the series converge and diverge together. If one series converge, another will converge. If one series diverge, another series will diverge. So what is limit? Actually, let's check limit. So what is limit? Limit n tending to infinity an upon dn. Limit n tending to infinity 2n plus 1 upon n plus 1 square. This is 1 by n. So n will go above. Limit n tending to infinity. This is 2n square plus n upon n plus 1 square. Okay. So you can take n square outside common. So n square 2 plus 1 upon n. So this is n square 1 plus n square. So this is cancelled out. And then what is the limit? Limit is 2 plus 0 upon 1 plus 0 square. That is 2. So this implies limit n tending to infinity an upon dn is equal to d. That is 0 and 2. 2 is finite number. Finite and non-zero. Since, so therefore, by limit comparison, test part 1, we conclude that the series summation n goes to 1 to infinity 2n plus 1 upon n plus 1 square is divergent. The given series is divergent. Okay. The given series is divergent. Okay. Now we come to next example. Example 2. Is the following series convergent? What is the series? Series is given 1 upon 1 plus 1 upon 3 plus 1 upon 7 plus 1 upon 15 and so on like that. Solution. So how we can write this series? This series is nothing but summation n goes to 1 to infinity. What is the nth term? Nth term is given by 1 upon. In numerator 1 is coming. And this is 2 to the power n minus 1. Use check. This will come like this. Okay. So what is the an? An is equal to 1 upon 2 to the power n minus 1. That is greater than 0. This implies this is positive term series. Okay. Positive term series. This is positive term series. Now what will be the choice of Bn? You take Bn is equal to 1 upon 2 to the power n. Then this series summation n goes to 1. Bn is equal to summation also positive term series is also, because this is greater than 0, also positive term series. Now this series summation n goes to 1 to infinity, Bn is equal to summation n goes to infinity is convergent, because this is a geometric series, because this is geometric series, because this is geometric series with common ratio r less than 1. What is common ratio? Common ratio is 1 by 2. The series common ratio is 1 by 2 and 1 by 2 is less than 1. If a geometric series has common ratio less than 1, whose numerical value is less than 1, that the series always converges. So this implies this series is convergent. Now what is the limit of n tending to infinity? An upon Bn. The limit n tending to infinity. This is 1 upon 2 to the power n minus 1 upon 1 upon 2 to the power n. So what will be this? So this is equal to limit n tending to infinity 2 to the power n upon 2 to the power n minus 1. How to write this? Limit n tending to infinity 1 upon 1 minus 2 to the power n. So what is the limit? So this is 1 upon 1 minus 0, that is 1. That is non-zero, and 1 is finite number. Now again, by limit comparison test part 1, because Bn series is convergent, so this implies this series summation n goes to 1 to infinity 1 upon 2 to the power n minus 1 is convergent. Okay. So next question. Question example 3. Example 3. Is this following series convergent? What is the series 1 plus 2 log 2 upon 9 plus 1 plus 3 log 3 upon 14 plus 1 plus 4 log 4 upon 21. Okay. So solution. So how to write this series in a summation form? What is the nth term of this series? Nth term is 1 plus n log n, and in denominator it is, what is this? N square plus 5. So I am starting by this way, n goes to 2 to infinity. You can also write like that, okay, no problem. Or you can add n plus 1 and start n goes to 1 to infinity. It does not matter, okay. So what is this? Now what is the nth term? An is 1 plus n log n square plus 5, that is greater than 0. So this This is positive term series. Okay, positive term series. Now, what is Bn? What is the choice of Bn? You can choose. If you have to guess it, Bn should be, if I can take 1 by n, the limit will, numerator denominator will be power n square, it will be there. So after cancelling n square, its limit will be finite. That is the idea. Okay. Take, then this n goes to 1 to n, Bn is equal to n goes to 1 to infinity. 1n is positive term series. Now see that this series is also divergent. This series n goes to 1 to infinity. Bn is equal to summation n goes to 1 to infinity. 1 upon n is divergent. Now limit n tending to infinity an upon bn. What is this? This is limit n tending to infinity. So what will this is here is 1 plus n log n, and this is n square plus 5. Okay, in denominator it is 1 by n. Okay, so what you will write? Okay, so what you will write? Okay, so what is this? You can take n outside, so limit n tending to infinity, it will be n square, and this will be 1 upon n plus log n upon n square, 1 plus 5 upon n square. So this is cancel out. Okay, so this is 0 plus infinity upon 1 plus 0. This is 0. Okay, now this is going to be infinity, and this series 1 upon n is divergent. Okay, now by limit comparison test part 3, limit comparison test part 3, we conclude that the series summation n goes to 1 to infinity 1 plus n log n upon n square plus 5 is divergent. Okay, by part 3. Okay, okay, is divergent. Now example 4, does this series summation n goes to 1 to infinity log n okay upon n to power 3 by 2 converge. Okay. Solution. We know that log 1 value is 0. You see that n goes to 1 to infinity. Log n upon n 3 by 2 can, because log 1 is 0. So this is starts from n goes to 2 to infinity. Log n upon n 3 by 2. Now what is an? An is here. So this is my an. So an is equal to this log n upon n to the power 3 by 2. So this implies this is a positive term series. Okay. Now what I will choose bn. Bn. So take bn is equal to 1 upon n to the power 5 by 4. Then this series n goes to 1 to infinity. Vn is summation n goes to 1 to infinity 1 upon 5 n to the power 5 by 4. N to the power 5 by 4 is positive term series. This is positive term. Here what is P? P is 5 by 4. That is greater than this. So this implies this series is convergent. Because in auxiliary series, if P is greater than 1, this series is convergent. Okay. Now what is the limit? What is the limit actually? Limit n tending to infinity an upon bn. What is this? Limit is n tending to infinity. So log n upon n to the power 3 by 2, and this is divided by n to the power 5 by 4. So after solving it, what you will get? Limit n tending to infinity log n upon n to the power 3 by 2 minus 5 by 4. Okay. So this is limit n tending to infinity log n and n to the power 1 by 4. So infinity upon infinity form. This is indeterminate form. Minute form. Using L'Hospital rule. L'Hospital rule. So what you will get? Limit n tending to infinity. This is 1 upon n, and this is 1 upon 6 into n to the power. This is 1 by 4. So it is 3 by 4. Okay. By L'Hospital rule. So what is this? Limit n tending to infinity. So 1 upon 6, this is 6. 6 will come out, and this is n to the power 1 by 4. That is again 0. Okay. So this limit coming 0, since now by limit comparison test part 2, the given series summation n goes to 1 to infinity log n upon n to the power 3 by 2 is convergent. Okay, this is convergent. Now another example we are seeing. Example 5 is the following series convergent. What is the series summation n goes to 1 to infinity sine 1 upon n? Solution. So you see that in summation n goes to 1 to infinity sine 1 upon n, what is the an? What is the an? An is equal to sine 1 upon n greater than 0 for all n belongs to n. So this implies this is positive term series. Okay. Now take Bn is equal to 1 by 2, that is greater than 0. This implies this series Bn is equal to summation n goes to 1 to infinity is positive term series. And we know that this series is divergent also. Also this series n goes to 1 to infinity 1 upon n is divergent. Now what is the limit? Limit n tending to infinity sine. What is an upon bn? An upon bn. What is this? This is limit n tending to infinity sine 1 upon n 1 upon n. Okay. So put 1 upon n is equal to theta. Then this is limit theta tending to 0 sine theta upon theta. That is always 1. That is non-zero and 1 is finite. Okay. So limit is finite and 0. By limit comparison test 1. By limit comparison test part 1, the given series summation n goes to 1 to infinity sine 1 upon n is divergent. Because summation Bn series is divergent. Now example 6. Does the given series converges? What is the given series summation n goes to 1 to infinity 1 upon n to the power 1 upon n plus 1. Okay. Solution. So what is this is given series. This is positive term series. Okay. Positive term series. So what is an? An is 1 upon n to the power 1 plus n plus 1. Now bn, take bn is equal to 1 upon n. Then limit n tending to infinity an upon bn. What is this? What you will get after dividing, it will be limit n tending to infinity 1 upon n to the power 1 upon n. After solving it, 1 upon n will be cut down. So what is the limit of this? This is limit of 1 upon limit n tending to infinity n to the power 1 upon. This limit is always 1. So this is 1. This is non-zero. and one is finite number. Okay. Now we know that this series is divergent. This series summation n goes to 1 to infinity b. So this series, the n series is nothing but this series. This series is divergent. Okay. So by limit comparison test part 1, the series, given series summation n goes to 1 to infinity 1 upon 1 to the power n plus 1 on n diverges. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture. Thank you very much.